Welcome to Lamar University and this year's JASON event, the best of JASON.
I'm Victor Thornton from St. Anne's Catholic School and an Argo co-host.
I'm Jasmine Reyes from Thomas Jefferson Middle School and your other co-host.
First, we'll follow our Argos as they cruise the Neches River, investigating its marshes and swamps and their water quality.
Then we will join our science superstars while they demonstrate Newton's first law of motion.
Next, the superstars will show how the second and third laws of motion work.
Finally, we will go to the Shangri-La Nature Center and see how they use alternative sources of energy to keep our air clean. So, let's head down the river.
Today we join Dr. Michael Hoke, a longtime science educator and director of the Neches River Adventures, as he takes our Argos down the Neches to investigate and compare saltwater and freshwater communities along the river. On the cruise, the Argos will learn the importance of biomonitoring, which uses the presence of small aquatic organisms to determine the local environmental quality of the river.
In ocean water, there are 35 parts per thousand of salt. Would you expect there to be that much in this water? Why wouldn't there be that much in this water? Anybody?
Because there's fresh water too.
There's fresh water too. It's a mixture. We sometimes call it brackish water. So it's a mixture, and we measured about 4 parts per thousand a while ago. Is that fresh? Well, it's not perfectly fresh. It has a little salt in it, but it's not really very salty. The good thing about an ecosystem like this, the good thing about it is since you have not too much salt and not too much fresh, you get organisms from both ecosystems. We call it an ecotone, where you get salt water and fresh water overlapping, a brackish system. So sometimes we catch saltwater fish here. I'm told there's been sharks up in here. Sometimes we catch, freshwater here, and sometimes you catch both. So today we'll see what we catch as we go farther up. Basically what we're doing is we started up here. This is Sabine Lake, and then right here is the Gulf of Mexico. You're standing in the Gulf of Mexico. So we want to head down here where you start seeing the coastal marsh. Y'all know what the difference between marsh and swamp is? What a primary difference is? It's trees. Typically a swamp is an area that has a lot of trees. They call one of the ones we have here is called the Cypress Tupelo swamp, and it has two kinds of trees. This is real hard. What are the two kinds of trees in the Cypress Tupelo swamp? Cypress. And? Tupelo. Those are the two kinds of trees. Well, in this marsh, we have a marsh that's basically, as we get down here, and it's called Spartina marsh. Why would you guess it would be called Spartina marsh? Spartina, which is a marsh plant that is technically, and this area in here, can y'all look over here what's beginning to change in this area? We're getting a lot of bamboo. Still a few trees on the higher areas here, which can you see it's beginning to change? Beginning to be more marsh-like and less swamp-like. Slowly what's going to happen is the vegetation is going to change as we get down more toward the saltwater area.
In the salt marsh, the Argos use handheld discovery scopes to see the tiny organisms which inhabit the bottom. These include crabs and other salt-loving animals which are not found in the freshwater swamps upriver.
Look at the ecosystem and how much it's changed. Do y'all know these things that are sticking out like little castles here, what they're called?
Cypress trees.
They're called cypress knees. I thought you were going to say stalactites. And they're part of the root system of the big cypress trees. See, almost every tree out here has a unique shape at the bottom. It gets bigger at the bottom. You might say they have bigger bottoms, right? Okay. Almost every tree out here does. But are they all the same kind of tree? Look. Just look to see if they're the same kind. Some of them have some kind of leaves and some of them have different, right? So are they all the same kind of tree? No, they're not. But they still have the same adaptation. What would be the advantage of having a big bottom if you lived in a muddy environment?
It would have like more places to rest on.
Right. So it's an adaptation to keep from falling over in a wet environment. And it's called buttressing. Buttressing. I love this environment. Look at these. Look at this. That is a big cypress knee. Cypress knees are also tools for living because they help the plant keep it from falling over. You all hear about tropical rainforest, right? You've all heard about that. Save the tropical rainforest. It's an important thing. Well, it is important. But there's as much biomass, living matter, stuff that's alive, that has mass in this ecosystem, as there is in the tropical rainforest in the summer. Yeah, so here we go. So go ahead and take one. That's yours. Ooh, gross.
There's the good stuff.
Put a little bit less water this time. And you get this whole one and I'll get him another one. Notice how much life there is in here.
Oh wow, look at that.
He's got a bunch of fish. Oh look, oh this is a good one.
Oh yeah, you too. Ooh,
This is a great one.
that's cool.
A dropper, if I could borrow, a real dropper. I'm gonna isolate him where we can see him. Look at this bloodworm. This is a typical bloodworm. Let's see if I can get him in there. Now bloodworms are larvae of midges. Midges they kind of look like mosquitoes, but they don't bite like mosquitoes. And this is indicative of an area that has low oxygen. Why would the water have low oxygen out here? Well, this tells the story. There's a lot of things in this water that are decaying, and they eat up oxygen as they decay, so it has low oxygen. Oh, neat, another bloodworm.
Is it? It
Yeah.
look the same.
I don't know though, it looks a little bit too
Yeah,
big.
It looks long and it's
Yeah.
just different shape.
Yeah. Oh, look at this one. This is excellent. You can see right through him.
Yeah.
Yeah, it's a nematode.
It sure is.
It's not a larva.
Curl
The
around.
curl.
Yeah, it's not a larva, it's a nematode. He's full grown. He's the papa, the daddy.
That's another way that we tell water quality, is by what kind of creatures we're finding.
Would you think this would be a neat thing to do if you had a lot of time in the world? Yes. Yeah, I do too. You know, if you can take them out and show them things they've never seen before and develop that sense of wonder, it'll continue throughout their lives and it'll kind of drive them to want to learn more and protect the environment. You know, it's a very difficult position because people can be journalism majors, they can be biology majors, they can be geology majors, they can be almost any type of major, but you know, mainly a background in science and communication and a willingness to learn and to work with kids. That's probably the most important thing.
My name is Kathy Barrios, and I'm the Environmental Education Coordinator for the Neches River Adventures. We just started last spring, and we're growing, and it's going to be a wonderful project. We're very, very excited about all the possibilities. I hope to see student scientists coming out here, working with the environment, becoming good stewards of the environment, becoming aware of all the diversity in this area.
I thought it was cool being able to pick up things at the bottom of the water and like going through and see what was in there.
Throwing the fishing net out and catching the stuff and releasing it, the shrimp and fish.
I liked finding all the little larvae and worms and then looking at them in the microscope and all that stuff.
I liked it when we saw the living things. We saw them on that TV with the big microscope.
Miss Kathy and I are going to do an advertisement, so y'all listen. We have, this program is available to your school. Now for kids your age, they would come straight out here and they could have about 2 hours on the trip. We wouldn't have to go down to the other side or do that side, although we're looking into going the other side now. But so it's a free program. You can come out here with one class at a time. If you're in Beaumont School District, we will help you this 1 year by paying your busing. We got one of our donors said for this 1 year they would help Beaumont School District because they've had some problems. But all the other school districts, y'all can come out here absolutely free and spend the day with us and learn about this unique ecosystem. And it's, if you look around, I told him a while ago, I said, if this isn't really special to you, then you need to have your special part checked, because this is a really special area and it's a special ecosystem, and we never know what we're going to find. I mean, every time we come out here, we find something different. So, we invite you to tell your teachers about it and come out here and join us.
River water that is a mixture of fresh and salt water is called A, muddy, B, brackish, or C, marine. The answer is B, brackish. Now we'll meet some of Southeast Texas science superstars as they demonstrate Newton's first law of motion to the Argos and make learning physics an action-packed event.
This is a good example of Newton's first law of inertia, which is an object in rest will stay in rest, while an object in motion will stay in motion unless acted upon by an unbalanced force. And in this case, air is the unbalanced force that's acting upon this ring, which kind of makes it dissolve. Or it could be a close-up wall if it hits it.
Well, the reason the plates didn't fall off is because this tablecloth is so slick, and when I pull it out from under these plates, it doesn't cause enough friction to break the inertia of the plates. And friction is the tendency of this object to stay at rest or stay in motion unless acted upon by an unbalanced force. See, the thing is, since there's more plates, it creates more mass on top of the tablecloth. And make sure when you pull it, you pull straight back. And put your hands right in the middle of the cloth, okay? Okay. You ready? I guess. Good job.
Good job, man.
So this is another very good demonstration on Newton's first law. So whenever you turn on the leaf blower, the air pushes you up, so you're like floating on air. And air is very, very frictionless. So when they push you across the floor, it's kind of hard to stop because you get a good motion going. There's nothing there to stop you except when you turn off by yourself.
This is an example of Newton's first law of inertia. And what I have right here is I have a dime on top of this ring. And whenever I pull the ring out from underneath the dime, and the dime is going to go into the beaker. 3, 2, 1. And the reason the dime came into the beaker is because whenever I pulled the ring out from underneath it, the gravity pulled the dime into the bottle. Alright, so whenever you pull through, you go straight through. You don't just stop here. You have to go all the way through when you pull. Good job.
I think my favorite part was the tablecloth. I learned a variety of things. The main point was on inertia and force and Newton laws. I believe it's important because it's not just for high school or middle school. It should be for everybody, because that way next time you pick up a baseball or an object and throw it, you'll know why it goes down or it does what it does. And I believe everybody should know. That way they could have that curiosity in their head just solved.
The idea that resting objects tend to stay at rest is part of Newton's A, first law of motion, B, second law of motion, or C, Newton's third law of motion? The answer is A, first law of motion. Now that we know Newton's first law of motion, our superstars are going to put Newton's second and third laws into action. Let's see how the Argos react to this challenge.
Today I will be showing you Newton's second law. And Newton's second law is that force equals mass times acceleration. So if we have 1 mass, which is 1 marble, and we have 2 acceleration, which is 2 Jenga blocks, we will put it on the ruler and get 6 centimeters. So if we have a mass of 2 marbles and the same acceleration of 2 Jenga blocks, we will get 12 centimeters. So if we will go over on this side, we will see what happens when you have 4 Jenga blocks with an acceleration of 4.
$14 centimeters. Now we have 2 marbles and 4 Jenga blocks. 28 centimeters.
This is a demonstration of Newton's second and third law. The second one states that force equals mass times acceleration, and the third one states that for every action there's an equal and opposite reaction. So if I pull one, you get the same force on the other side. If I do 2, you have the mass of 2 and the acceleration of the drop, and it comes out the same. If I do 1 on each side, it's an equal force, so the one in the middle doesn't move.
So here we have our Alka-Seltzer rockets, and this shows Newton's third law, which is for every action there's an equal and opposite reaction. So here we're gonna get a capsule. We fill it about halfway up with water. We're gonna drop a half of an Alka-Seltzer in it, put the cap on it, shake it up, load it in here with the end of the capsule facing backwards, and the gases are gonna push. There's so much gas packed in it, it's gonna push the capsule forward and the gases back. Now, once the angle is adjusted, either higher or lower, it will make it go farther. And this is all due to opposite reactions and equal reactions. Because of the water in the Alka-Seltzer, it's pushing so much force on the back of the cap, that way it shoots the end part forward. You like to try and see if you can get farther than me? Okay, get a capsule, get half of an Alka-Seltzer, and a cap. Okay, now shake it up a little bit. Okay, now hold it steady right here on the base.
This is our red rocket wagon. It is like the Seltzer rockets. It has the same concept. For instance, this fire extinguisher is full of CO2. Now the air coming out of this is no lighter than this foam brick, but it's coming out fast enough to move me and the wagon all the way over there.
Well, wasn't that fantastic? Have you ever seen anything like that?
No.
That's called our little red rocket wagon. We use it to introduce Newton's laws. And probably because you're all in the 8th or 9th grade, you know a little bit about Newton's laws, but you know, there are 3 laws involved. Newton's first law, which is sometimes called the law of inertia. The second law, which is considered Newton's probably most fantastic law, it's force equal mass time acceleration. And when he came up with that law, it broke ground for all of science. Previous is no one had ever put numbers on that type of physics of movement. The third law involves the fact that for every action there's an equal and opposite reaction, and we can do lots of activities involved in that.
What kind of forces keep hard hit baseballs from continuing to go over the home run fence?
Alan Shepard went to the moon. Y'all, you may remember, they have a picture of, he took and he hit a golf ball, and we don't know how far that golf ball went. It went a long way because there weren't any of the forces that we have on Earth slowing it down. On Earth, we have the major force is the wind resistance. When the ball is hit, it's being, the unbalanced force is pushing against the ball, and therefore it doesn't go very far, but also gravity. So it's a combination of those two forces. So you can't hit a ball a long way on Earth, but if you could go to the moon where there's not air there and the gravity is 1/6, you could hit the ball probably 800 or 900 yards pretty easy.
2 hands, but I'm going to try a little sand trap shot here. It looks like a slice to me, Al. There we go. Miles and miles and miles.
My favorite experiment was the peel rocket launcher because you know, it was fun and I got to shoot it out and stuff like that.
My favorite part would have to be riding the rocket. With a little bit of a mishap there. Oh God. She was gonna hit the camera.
Well, in the real world, these laws relate because whenever you're on a diving board and you push on the diving board, that's the action force, and the reaction force is the diving board pushing back on you, causing you to go into the water.
One example that I can give is like NASA. They have to make sure that they have enough push force, so that the rocket will go as far as they need it to.
Newton's third law of motion states that for every action there is A, an unequal reaction, B, an equal and opposite reaction, or C, no reaction. The answer is B, an equal and opposite reaction. For our last exploration, the Argos traveled to Shangri-La Botanical Gardens in Orange, Texas, where science education expert Noelle Jordan shows them how Shangri-La earned the title of one of the most environmentally friendly complexes in the world. To shrink its environmental footprint, Shangri-La uses renewable energy rather than fossil fuels. This includes solar and wind-powered electricity and a geothermal system for heating and cooling.
Shangri-La is a pretty awesome place. We are a botanical garden, which means we have lots of pretty flowers. We're a nature center, which means we have about 225 acres that are all natural, so we just let nature do what it's going to do. And we're one of the top 10 green projects in the world. In 2009, we were designated one of the top 10 green projects in where? The world, the whole world. So we did a whole lot to try to be green. What does that mean, to be green?
Eco-friendly.
Eco-friendly, say it again. Clean energy. Any other ideas?
Conservative.
Conservative, yeah. We're trying to conserve energy so that we can be green. That's exactly right. So we've done a whole lot of work to try to be green and be earth-friendly and eco-friendly. And so today what we're going to talk about while you guys are here are how we specifically do that. What are the primary energy sources that folks use?
Coal.
Coal, that's a good one. Coal, what else?
Fossil fuels.
Fossil fuels, good. Coal is one of those fossil fuels. Can you think of another kind of fossil fuel?
Petroleum.
Petroleum, or let's call it oil, okay? Yep, good. Very good. Jessica, you had your hand up?
Yes, water.
Water, good. Does anybody know the fancy name for water power?
Hydroelectric.
Hydroelectric, yeah, hydropower, good, good. AJ?
Nuclear.
Nuclear. Nuclear energy, yeah. What's another energy source? Yes.
Solar radiation.
Solar, good. Oh, let's see, let's put solar here. Jessica?
Wind.
Wind. Jackson?
Geothermal.
Geothermal. Ooh, I love that one. Geothermal. Let's put geothermal down there.
Biomass.
AJ, biomass. What is biomass? Yes.
Ethanol. It's made out of wastes that we use from every day.
Good. Made out of living things, right? Like trees and corn and things like that. Good, good, good. Biomass. So what's our last one then? Natural gas. Yes, natural gas. So I sort of sorted them for us. Why did I sort them the way I did? Yes, ma'am, what do you think?
Renewable and non-renewable.
Good, renewable and non-renewable sources. So renewable, right? Non-renewable. So let's dig into these words a little bit. What does renewable mean?
It means it like replenishes itself.
Good, yeah, it's going to constantly keep coming back, right? We can plant trees and in 25 years they'll grow back. Non-renewable means what?
It doesn't get produced, it's basically the opposite of renewable. It doesn't come back for another millions or billions of years.
Good, very good. So at some point we will run out of non-renewable stuff, right? There's a finite amount of it on the earth, and we'll eventually run out. Good. So at Shangri-La, we decided to focus on renewable energy with our major focus on solar. We use some wind power, and we use geothermal. So those are the three primary things that we're going to be exploring today. We're going to take a boat ride on an electric boat, no lots. We'll see some solar panels, also called photovoltaic panels. And then we'll look at all the wells where we drilled holes for the pipes for the geothermal, and you'll get to see all those pipes. Okay, so that's what our day is going to look like. Any questions before we get started? All right, let's do it. So there's tons of wildlife out here. There's lots of trees. We've got other ecosystems at Shangri-La. There's a forest area and a meadow area. And all of these alternative energy sources that we're talking about, one of the reasons is so that we can protect all these wild areas, these natural areas. When we use our electric engines, are we doing much to pollute? No. So not only do we not have to worry about spilling gas in the bayou when we fill up our gas engine, but our electricity, the source of the electricity for these engines is what? Where do we get 40% of our electricity?
Solar.
Solar, yeah. And then even when we have to use electricity from the grid, what green energy are we getting from the grid? Wind power. Very good. Yeah. So we're clean all the way around. And so we talked a little bit earlier about fossil fuels, the coal, oil, and the natural gas. And somebody said one of the great reasons for using renewable energy is that it's also clean energy. And so what that means is we're not, spewing pollution into the environment. Reasons to use renewable energy. What do you guys think? What are some reasons to use renewable energy like we use here? It's better for the environment. It's clean, which means it's better for the environment. Yeah, and so there are some pros and cons of using a gas engine versus an electric engine. The gas engine is going to be faster, and if we had a storm on our tail and we were trying to get back really fast, we would use the gas engine and the boat would go a little bit faster. But what are some of the downsides of using gas engines? Pollution, yeah. And so sometimes you can tell, even when we first turn on the gas engine, you get a big cloud of smoke because it'll burn some oil right away. And so when we use our electric engines, we don't ever get that. There's no oil to burn, okay? So we try to use those electric engines as much as possible. So this is a solar panel. Now technically it's 4 different panels. You can see there are 4 different rectangles. We have a total of 36 solar panels at Shangri-La, so 36 of those little rectangles. And that gives us about 40% of our electricity. So not quite half of our electricity comes from solar power. So even on a day that's cloudy, like today, there's enough sun that the solar panel can do its thing. So we get 40% from this, so we need to get 60% of our electricity from the grid. Well, partly some of the electricity that's in that grid comes from wind power from Texas. Texas, in fact, is the #1 state in the country that makes the most electricity from wind power.
Not this area.
No, not this area. Yeah, you've got to go out west or south to the Corpus Christi area. There are some windmills down there too. So the sun comes out, shines on the photovoltaic cells, the electrons start jumping. Okay, so the electrons just jump from one atom to the next down the wires that go underground into that building to make our lights and fans work. Now we're going to shift a little bit and talk about geothermal.
Now this is something that a lot of people, it's a little harder to understand. So it's going to make it real simple, okay? So geo means what? Earth or rock, good. And therm means what? Heat. So you would expect things to warm up by somehow using the earth. Inner earth. Right? Okay, yeah, so inner earth, which means we're going to be digging holes, right? We're going to be digging holes. So at Shangri-La, we use geothermal for our heating and our air conditioning. And how we do that, in this area out here where these picnic tables are, we have dug 12 holes that are 300 feet deep. And inside these holes we have pipes, and the pipes run down one hole and back up that hole, and then it jogs over and down the next hole and up, and so it's like a big roller coaster, right? And then there's water running through those pipes. So the water goes through the pipes and it cools off as it comes back, and then we blow air over those pipes because the pipes are cooler, and then that air blows into the buildings, and so that's what helps us with our air conditioning. And then we just reverse it a little bit for the heat. This is the room that has all the pipes in it for the geothermal wells. So there's water running through all these pipes. All the pipes are labeled and there are arrows that show the direction of the water flow. But basically they're coming to and from those wells that we talked about that are how deep again? 300 feet. 300 feet. The water comes from the well into this room through all of these pipes. At some point, we blow air across a whole bunch of smaller pipes, and that cools the air down or warms it up, depending on what season it is outside and how comfortable we want to be in the office. They go throughout the entire system. So that one that says to the Nature Discovery Center, it leaves this building, it goes underground all the way out to those two buildings that we passed on the way to the boat, and then it comes back. And so most of them are a closed system. Okay, so it's just a great big loop going out to other buildings and coming back. So at Shangri-La, we use a lot of alternative energy sources, like, what are they again? Solar, wind, and geothermal for the heating and cooling. Very good. So in addition to that, we've used a lot of elements in the design of the buildings to help conserve that energy. For example, the roofs around here reflect heat back out into the environment so that we don't have to work so hard to cool down the building. Y'all saw the insulation inside. What is our insulation made of again?
Soybeans.
Soybeans. And why soybeans?
It's easy.
They're renewable. Plentiful, they're renewable, it's easy. We grow a huge crop every year, so very good, a highly renewable resource. Now another thing that I notice when I look at all these buildings is there's a lot of glass. What do you think the purpose of that is? Why glass? Natural light, so that we have to use less electricity for lighting. If you were to walk into a glass building, what would the temperature be? Warmer, right? And so windows give us, it's called passive lighting and passive heating. So in the winter, you don't have to work so hard to use all that electricity to heat things up and for the lights.
Just the whole experience. I mean, I enjoyed it all.
Yeah.
Everything. Learning about what's good for the environment, and renewable energy is better for the environment because it's cleaner, it's healthier for us. And
I learned that the switches for the lights are really cool, and they're on a timer, and after the time goes up, then the light goes out, and I just thought that was really cool.
I learned a lot about energy and different environmental clean things that you can use instead of fuel.
In the pipe room, that all the pipes go down 300 feet, so that way they cool off and they don't all stay hot from the friction that they would create in the pipes.
The docks are made out of plastic instead of wood to save wood and stuff. Mm-hmm. And how the roofs reflect light off, so it's easy to cool down the buildings. Alternative energy is the way to go.
I learned a lot about geothermal energy, mainly the most, and how you have to dig the pipes really deep and stuff, and insulation and stuff. And we were looking at the soybean insulation. I didn't know you could have soybeans for insulation. Really cool.
Today I learned different ways and methods to
make energy cleaner and more efficient for the earth and ecosystems, like solar energy and wind energy and geothermal for now or the future. It's more efficient for not only us humans, but for ecosystems and like pollution and everything. That can all stop if we all use these new methods or old methods, and it's more renewable too.
Which of these energy sources does Shangri-La use? A. Natural gas, B. Nuclear energy, or C. Solar energy? The answer is C. Solar energy.
Thanks for coming to this year's JASON program.
Remember, JASON needs Argos like you for national JASON missions.
If you would like to apply to be a National Argo, visit the JASON website at www.jason.org for details. And be sure to come back next year when JASON explores our wetlands.